All right, so today we are finishing up our section on chapter 4.3. So this is the second day of dividing polynomials. So we are using a method called synthetic division. So this is kind of known as like a shortcut method. So you can use this instead of doing long division. It's kind of just whatever works best for you. So when we are doing this, we still have this first polynomial is our dividend. So this is our dividend. And the second, what we're dividing by, this is our divisor. So now we want our divisor in the form x minus k. And our divisor is already in this form. It's already x minus 3, so our k value here is 3. Okay, so now what we're going to do is kind of draw like an upside down division sign. And in this box, we're going to put the coefficients from our dividend. So the coefficients are -1, 4, and because we don't have an x to the first power term, I'm going to put a 0. And then we have our constant 9. And then we're going to put this 3 on the outside, and that's how we start synthetic division. Now what we're going to do is bring down this -1, and we're going to multiply 3 times this -1 and put that product here. So now we have -3 in this second area right here. So now we're going to add together 4 and -3. So 4 plus -3, or 4 minus 3, is just going to give us 1. And now I'm multiplying 1 times 3, which is going to go here. So 3 is my product there. So then I'm adding together 0 plus 3, which gives me 3. And then 3 times 3 gives me 9. And then I'm adding together 9 plus 9, which gives me 18. Oops. Which gives me 18. All right, so now we're just given coefficients to our quotient. And so now we have to create our quotient with the variables as well. So since we started with an x to the third power, we started with a third degree polynomial, our quotient should be a second degree polynomial because we divided by a polynomial to the first degree. So we should get an x squared to be our highest term. So with that being said, we're going to have -1 x squared plus 1x plus 3. And then we have this leftover right here. So this 18, this is actually our remainder. And so from our video yesterday, we wrote our remainders like this. So we added them to our quotient, and so we're going to add 18 and put that over our divisor, which is x minus 3. And that is our quotient. Okay, let's try one more. I'm going to set it up in the box for you, and then I want to see if we can pause the video and figure this one out on your own. So I'm putting in the coefficients. So 3, -2, 2, and -5. And remember, if you don't have a term, remember to always put in a 0 because you have to keep that place value. And so now we need to find our k value to put on the outside. So we have x plus 1 now. And so that's not quite in the form x minus k. And so to get it in that form, we would have to have our k value be -1. So we're going to put a -1 on the outside and start by bringing down this 3. Okay, now go ahead and pause the video and see if you can determine the rest. All right, so hopefully you paused the video and you found that -1 times 3 gives you -3. When you add those together, you get -5. -1 times -5 gives you +5. 5 plus 2 gives you 7. -1 times 7 gives you -7. When you add those together, you should get 12. And this negative 12, this is our remainder. And so our polynomial here should be 3x to the second power minus 5x plus 7 minus 12 over x plus 1. All right, so now hopefully you're here, and now we're just going to go ahead and check what we got. So this is called the remainder theorem. And so we're going to use the remainder theorem to check your remainder is correct for the examples above. So our examples here, again, we have the polynomial for a is f of x equals negative x to the third plus 4x to the second plus 9. So now what the remainder theorem tells us is that we want to input in our k value, which remember here our k value was 3, and we are going to input our k value, and we should get our remainder as our output. So what I mean by that is we're going to input 3 and substitute in a 3 for every x that we see. So you will get, when you substitute that in, you should get 3 to the third power plus 4 times 3 to the second power plus 9. Now we're going to do exponents first in order to evaluate this. So 3 to the third power is going to give us 27, and don't forget that negative on the outside. And then we have 3 to the second power, which is going to give us 9, and then plus 9. Okay, now we're going to simplify this even further, and negative 1 times 27 is going to give us negative 27. 4 times 9 is 36, and bringing down our plus 9. Now if we were to add all of this together, we will get 18. And since 18 is a remainder that we got above, we know we are correct. Okay, let's do the second one. I'm going to set this one up with the polynomial and your k value, and then I want you to go through and just double check your work, input it just like we did in part A, and see if we did it correctly above. So we should have f of x equals 3x cubed minus 2x squared plus 2x minus 5. And your k value is negative 1. So go ahead and pause the video and try that one. All right, so hopefully you pause the video and you got f of negative 1 is equal to 3 times negative 1 to the third power minus 2 times negative 1 to the second power plus 2 times negative 1 minus 5. Once you simplify that, you should get negative 3 minus 2 minus 2 minus 5, which when you simplify even further, you should get negative 12. And since this is the remainder that we got in the first section when we divided these polynomials, we know we are correct.